Hi, my name is Mr. Peck from Ideas Inc. School, and today we will be discussing the concept of energy. Energy can be defined as the capacity to do work, and the standard international unit for energy is joules. Let's begin by listing the different types of energy. Number 1 is chemical energy. This type of energy can be found in dry cells or batteries, and it can also be found in the food that we consume. For example, the energy stored in food is converted into kinetic energy to power the muscles in our bodies. Number 2 is nuclear energy. This type of energy is released by radioactive substances like uranium. Processes such as nuclear fusion, nuclear fission, and radioactive decay are sources of nuclear energy. For instance, nuclear power plants use nuclear fission to generate electricity. Number 3 is electrical energy. This type of energy is due to the flow of charged particles called electrons. We use electrical energy to power our electronic appliances at home, such as TVs, computers, and lights. Number 4 is mechanical energy, which can be further subdivided into two varieties: kinetic energy and potential energy. Kinetic energy is the energy that objects in motion possesses. For example, a car moving down the road has kinetic energy. Meanwhile, potential energy is often referred to as stored energy. There are two types of potential energy: elastic potential energy and gravitational potential energy. Elastic potential energy is associated with compressed and stretched springs or stretched ropes. For instance, a rubber band has elastic potential energy when it is stretched. On the other hand, gravitational potential energy is the type of energy that an object has due to its position or location. Examples of this include waterfalls and dams, where the water at the top has gravitational potential energy due to its height above the ground. Next, we will be listing down examples of renewable and non-renewable energy. These are some common sources of renewable energy. They are solar energy, wind energy, hydroelectric power, geothermal energy, tidal power, and biofuels. And the following are some common sources of non-renewable energy. They are fossil fuels, natural gas, and nuclear energy. Now, let's move on to an important principle known as the conservation of energy. The conservation of energy states that energy cannot be created nor destroyed. Energy can only be converted from one form to another or transferred from one body to another. Regardless, the total amount of energy of a closed system must be constant. For example, when a ball is thrown down from a height, the potential energy it had at the start is converted to kinetic energy as it falls due to gravity, and the total amount of energy in the system remains constant throughout the whole event. Let's investigate further. The formula for kinetic energy is half times m times v squared, where the m stands for mass in kilograms while the v stands for velocity in meters per second. The next formula we will look at is gravitational potential energy. It has a formula of m times j times h, where m stands for mass, g stands for gravitational acceleration at 10 meters per second squared, and h stands for height in meters. Please pause the audio to refer to the example in the notes. Let's begin. When the 3 kilograms nugget is at maximum height, it has a total GPE of 150 joules. We obtain this by taking its mass of 3 kilograms and multiplying it by the gravitational acceleration of 10 and the height of 5 meters. What happens when the nugget falls to half of its original height? At half height, the nugget will only have half of its original GPE. However, due to the conservation of energy, this 75 joules of energy cannot be lost. Instead, the 75 joules of GPE was converted to kinetic energy. And with this information, we can calculate the velocity of the falling nugget. The velocity can be found by equating 75 joules of kinetic energy to half times m v squared. And since the mass is 3 kilograms, the value of v squared will be 50. And thus rooting it will get us a velocity of 7.07 meters per second. But since the nugget is accelerating towards the ground, when will it reach maximum velocity? Maximum velocity occurs just before the nugget hits the ground. At this moment in time, all 150 joules of gravitational potential energy will be converted to kinetic energy. Thus, when we plug in 150 joules into the KE formula, we can calculate that the maximum velocity reached is 10 meters per second. Last but not least, please take note that the example stated earlier has a very important assumption. We are assuming that the nugget does not experience air resistance, and thus the energy conversion from GPE to KE is 100% efficient. In reality, some of the KE will be converted to other forms of energy like heat, thus the actual velocity will be lower than the theoretical one. Here is a fun fact. When astronauts first landed on the moon, they were asked to take this precious opportunity to test out this theory. The astronaut dropped a heavy object and a light object at the same height and at the same time. And you can guess what happened after. Both objects fell and reached the ground at the same time. But why is this the case? That is because the moon has no atmosphere. Hence, as the objects fell to the ground, they do not experience air resistance. If we equate the GPE formula to the KE formula, we will discover that the mass on both sides of the equation can be cancelled. Thus, the velocity of the falling object is not dependent on its mass. As a result, both objects will fall towards the ground with the same velocity. In the last part of the chapter, we will be talking about some common energy conversion scenarios. When switching on a torch light, the stored chemical energy in the battery is converted to electrical energy that flows through the wire. This energy is then converted to heat and light energy in the bulb. In a hydroelectric power station, since the water is stored at a high height, the body of water will possess gravitational potential energy. When the opening at the bottom of the dam is open, the gravitational potential energy is converted to kinetic energy as the water falls. This kinetic energy is then used to turn the turbines in a generator. The kinetic energy of the turning turbines will then be converted to electrical energy that can be transmitted to the electrical grid. However, this conversion is not efficient as some of the energy will be lost as heat due to the friction in the moving parts of machinery. Lastly, let's talk about the energy conversion that occurs when a bungee jumper jumps off a ledge. When the jumper is standing on the ledge, the body has maximum gravitational potential energy. As he falls, the gravitational potential energy is converted to kinetic energy. The jumper will have maximum kinetic energy when the rope has reached its maximum length. This is the length of the rope before it starts to extend. Upon reaching maximum length, the rope will then start to stretch due to its elasticity. When that happens, some of the kinetic energy will be converted and stored as elastic potential energy. And when the rope contracts, the elastic potential energy is converted back to kinetic energy as the jumper rebounds upwards. As a result, kinetic energy is subsequently converted back to gravitational potential energy as the jumper gains height again. However, this process is not efficient. During the jump, some of the energy is lost as heat due to air resistance and friction between the bungee cord and the jumper. Additionally, the rope is not fully elastic, therefore some elastic potential energy will also be lost as heat. This energy loss means that the jumper will not bounce back to their original height, and they will eventually come to a stop due to the dissipation of energy. Another interesting fact is about basketball players. Does the height of the player determine whether a slam dunk can be achieved? The answer is no, and there are plenty of evidences showing shorter players that can dunk as well as their taller counterparts. The secret lies in how much kinetic energy the player can generate when jumping. All the basketball player needs to do is jump with sufficient kinetic energy, either generated by muscles or by gaining momentum. With enough kinetic energy, the player will be able to convert this energy to gravitational potential energy and soar in height. We have come to the end of the chapter. If you have any doubts, please approach Mr. Peck. Thank you for listening and have a nice day.